Hello and welcome to another one of Mr. Chappell's Chemistry Screencasts. Today we're going to learn about using molarity and molality. What you'll learn in this screencast is how to use molarity and molality in calculations. Now, there are a couple of things that you're going to need. You're going to need a calculator, of course, and a periodic table. And you're going to need to know the definitions of molarity and molality. Now, there are two units that we use quite often in class, and the first one, far and away, we use more often than any other concentration unit, and that's molarity. And molarity is defined as moles of solute over liters of solution. Now notice it's liters of solution, not solvent. And the other unit that we sometimes use is called molality, and molality is defined as moles of solute over kilograms of solvent. Now notice that's kilograms of solvent, not liters of solvent. Let's go ahead and get started. Okay, here's our first problem, and we're being asked to calculate the molarity of a certain mass of sodium chloride in a certain volume of solution. So let's go ahead and write down the equation that we're going to apply. And that is molarity is equal to moles over liters. Now we don't know the moles right off the top of our head, so let's go ahead and take the 2.5 grams of sodium chloride and let's go ahead and convert that to moles. And for every 58 grams of sodium chloride, I'm going to get 1 mole. And the 58 grams, of course, is the molar mass for sodium chloride. And my calculator tells me that the answer to that is 0.0431 moles. So that's the number I put upstairs here. And downstairs I put the volume in liters, and hopefully it's already in liters. And the answer I get is 0.029 molar. And that's our answer to that question. Okay, for the next question, we're being asked what the volume is to give a needed amount of a certain reactant. And so we can start out with our molarity equation. Molarity is equal to moles over the volume. And I'm being asked for the volume, so what I'm going to do is multiply both sides by the volume. And let's go ahead and divide by the molarity, since I'm going to have to bring that over as well. Do that to both sides, and let's go ahead and cancel what cancels. And lo and behold, when I'm done, I get the volume is going to be equal to the number of moles divided by the molarity. Now, I know what the molarity is, but I don't know what the moles is yet, so let's go ahead and figure that out over here. I've got 4.5 grams of HCl. Go ahead and put that all over 1. Let's try that again. Put that all over 1. And for every 36 grams of HCl, I'm going to get 1 mole of HCl. And again, the 36 is the molar mass of hydrochloric acid, HCl. And my calculator tells me the answer to that is 0.125 moles. Okay, so that's what I put in my moles for N. 125 moles. And the molarity, we're told, is 1.5 molar. And the answer my calculator gives me is 0.083 liters. Now, we've not been asked to convert that to milliliters, so we'll just go ahead and leave it in liters. For our next problem, we're being asked for the mass contained in a certain volume of certain concentration of solution. So again, start out with our molarity equation. Only this time we're being asked to figure out the mass, and my only handle on that is the number of moles. So I'm going to multiply volume on both sides of the equation, and that goes ahead and cancels. And what I get is the number of moles is equal to the molarity times the volume. And the molarity is 2.7 molar, and that's going to be times 0.450 liters. It's got to be in liters in order for this to work. And my calculator tells me that I have, well, what does my calculator tell me? My calculator tells me that the number of moles is 2.73. And then lastly, to turn that into grams, I'll say 2.73 moles of CH2O, which is formaldehyde for those of you who are interested. Put it all over 1. And for every 1 mole CH2O, I'm going to get 30 grams. And my calculator tells me that the answer is, to two significant figures, 36 grams of CH2O. And that's how you do it. Okay, for our next problem, we're being asked to figure out the molality of a solution. So let's go ahead and write down our equation for molality. And molality is equal to moles over kilograms of solvent. And once again, I don't know what the moles are right off the top of my head. So let's go ahead and move over here and convert 5.5 grams of calcium iodide to moles. And the molar mass for calcium iodide is 294. And for every 294 grams, I get 1 mole. And the number of moles I get from that is 0.034. Whoops, don't get that at all. Well, let's go back and do it again. So 5.5 divided by 294, and the answer I get for that is 8. That's actually an 8 there. 42 times 10 to the power of -3, and that's moles of calcium iodide. Okay, well that's what I need to plug in up here. So that's 8.42 times 10 to the power of -3 moles all over kilograms, and this has to be in kilograms, so I'll go ahead and convert that real quick. And my final answer is 0.034 molal. And there you go. Okay, for our last problem, I was a little bit sneaky. I snuck in a dilution problem there. We're starting at a higher concentration. We're being asked to mix a lower concentration. And our equation for that is MA VA is equal to MB VB. So I'm being asked to figure out the volume that I'm starting with, which is VA. So I'm going to go ahead and divide both sides by the starting molarity. And what I get is the volume that I need to start with is going to be equal to the volume that I want to end with times the ratio between the ending concentration and the starting concentration. So let's just go ahead and plug in our numbers. So we are ending with 500 milliliters. Now you may be wondering why I'm not converting that to liters. Well, there's really no reason. You'll see why in a moment. And the ending concentration is 1.5 molar, and the starting concentration is a whopping 12 molar. Now you notice our units for molarity cancel, and the units that I end with are milliliters, and that's a perfectly acceptable way of expressing this answer. And so the final answer that I get to two significant figures is 62 milliliters of HCl. And that's how you do a dilution problem. And that concludes our lesson.